Fact that I'm truly myself.
A minute. Just 1 minute over. Shut the screen. Okay. Reasonably okay. Up to note theta is there that I can see. Everything is okay. Further adjustment I will not go. This is clear. That slightly change it. Consider PC. You can't see something here. I write here. Consider PC. Theta B is there. Theta C is there. Okay. I can write up to here. Up to correct here. Up here. Times. Just adjusting the board. Just a minute. Now okay. Display and voice. Voice, still mic is not on. I'll put the mic on. Just a minute. Tell me fast. Display and mic, both are okay? If both are okay, we'll solve. Display and mic, if both are okay, both okay. Okay. See, 1 minute. Actually, first of all, this question need not be solved. Compared to what we solved last time, this is nothing. But there is a purpose. Last time, see, all supports or settlements are there. So, therefore, you should be careful for delta. This time, only one support settlement. See, I am giving here support at B sinks by 120 by EI meter. Because you know, in case of beams, slope or deflection always comes in terms of EI. Last time I have given what? Support A rises by some 8 mm, support B sinks by 12 mm, etc. Numerical value. But this time, instead of numerical value, it is given in terms of EI. Why? Because actually the deflection comes in terms of EI only. But then they substitute numerical EI and give the value. Now, if they give numerical value of delta, see, the term is called what? 6 EI delta by L square. If delta is given numerical value, you should make a note. Then you require numerical value of EI. But here, your delta is given in terms of EI. It is something divided by EI given. But it is given in meter. Okay. Suppose they give in millimeter, you convert to meter. Why? Because we want in meter. It is given what? Delta settlement is what? 120 by EI meter. Now, when you substitute delta equal to anywhere, something divided by EI, Tell what happens. EI will get what? EI will get. What will happen to EI then? When you substitute for delta in terms of EI, something divided by EI, then it will get cancelled. So this question, numerical value of EI is not required. First make a note. I will not tell again and again. Clear now? Or you can do one thing. You substitute. Then you will realize, see, when they give support 6 by 8 mm, 10 mm like that, when you substitute, then suddenly you will feel, oh, without EI, how I can find the value? Correct? Yes or no? Suppose substitute 6 EI delta by L square. When you substitute delta numerical value, you suddenly realize, oh, to get the value, I require EI. But here, when you substitute, EI cancels. So there is no question of worrying about EI. This concept clear? Okay. One term clear. Then, second most important, this is for the group. See, one more thing. Most of the examinations, academic exams, they give 2 span beams. Why? Because of time limitation. Sometimes they give 2 span beams. Okay, now for you, but I am talking about regular batch, my BSK batch, that is changed over to indeterminate structure batch. This is the class number 21. I corrected it. There, all the questions, so far, I took 3 span. Tell yes or no. I took 3 span. Tell me yes or no. I took 3 span. All the questions so far. Yes. Then, for MD and Connie's method, see, there are 2 intermediate support. You distribute here, half carry over there. When you go there, distribute there, half carry over here. The chain reaction comes. In Connie's method also, what you do? At first support, you calculate contribution, go to next support, again come back here, chain reaction comes. But remember, the chain reaction will not come if there are only 2 span. See, if overhang is there, no problem. So, like I told 9 basic questions for 3 span, I told I will give it. Earliest possible, I will give the sheets for you. 9 basic questions for 3 span. Same way, there are 9 basic questions for 2 span. Tell me, 2 span means MD and Connie, that from here go there, from there go come here. That is not there. Only 1 cycle you get the answer. Clear now? Not for this question. If 2 spans are there, only 1 intermediate support. Therefore, that see, some performed my MD or Connie, here, there. Once again here, there. Here, there. That way, chain reaction. Table comes down, 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 down in MD method. Connie's method. Successive value, you have to change till repetition. But if only 2 spans are given, work is reduced. Lot of work is reduced. 1 cycle only. It is not called cycle. First, when you calculate first time, you get the answer. I will tell you an example. Long back, annual scheme. There used to be MDST Connie's method, long back. There was no, it was question of, that was in annual scheme. MDST Connie's method were there. Exam usually they give 3 span or portal frame. After solving all the questions, one examination, they are given 2 span. So many people got confused. What they done is, you come at B, distribute, carry over, then they start wondering where to go, where to go, where to go, where to go. Not where to go nowhere. Question is over. Clear? They start wondering. In the class, come to B, go to C, come to B, go to C, come to B, go to C. Here, B over. Next, where to go, where to go. What, where to go? Not there. Therefore, remember, all 2 span problems, overhang is not a criteria. If overhang is there, no problem. It is not considered. For what? The cycle all. Therefore, 2 span means work is drastically lesser. So today, I will finish this question by all 3 methods. Agreed? By all 3 methods. Today I will finish this question by all 3 methods. Over, clear? All three methods will finish today. Then I will give you 9 basic questions. That PDF I will give you 9 basic questions for 3 span workout. I will also give you 9 basic questions for 2 span. That also workout. Clear now? Okay, start. Now, this is the beam. Question is, I won't write question here. Question. Analyze the given continuous beam and draw SFD and BMD if support at B sinks by 120 by EI meter. I can take any support. One thing you remember, if a support sinks, its effect comes for either side span. See, suppose A sinks, effect is only for AB. If C sinks, effect is only for BC, for fixed end moment. But if B sinks, see, if B sinks, effect is there for both the span. Clear now? When you calculate FPM, suppose left support sinks, effect is only for AB. Why? AB, see, if A sinks, see, for example, see here, if A sinks, B and C, then for AB, delta will come, BC will not come. Same way, if support C sinks, then AB no effect for fixed end moment, final moment effect is there, and only BC, because B sinks, effect comes for both span. Okay, start. Now, I will not waste time, little fast I will do. Only. I wrote something because to save the time. So, slope reflection method. I explained everything earlier class, therefore you have to go through it. For a prismatic member XY, MXY equal to M bar XY, 2EI by L, 2 theta X plus theta Y, plus or minus 3 delta by L, where delta is vertical displacement of one end with respect to the other. Technically, it is not vertical. It is displacement. You should write a note there. Displacement perpendicular to the member or transverse displacement. Since the beam is horizontal, perpendicular means vertical. That's why I wrote vertical. Clear? Technically, it is not vertical. It is the transverse, perpendicular to member. But since our beam is horizontal, delta means vertical. Clear now? Fast, fast. That's why I wrote vertical. Technically what? Is the transverse displacement of one end with respect to other. And second note, what? One more note. Settlement is here. Settlement is given, that is delta is known. Therefore, this term is known. So push it this side. M bar xy plus 2EI by L into 3 delta by L is 6EI delta by L square plus usual. Now, remember, this is FPM due to loading. This is FPM due to delta. Now, regarding the sign, I will sign for this term. See, for this term sign. I am explaining now. Already explained earlier. What you have to do is, see, you write a note here. I am not writing. When you consider the member for getting the slope expression for moment, you put a sketch, clearly mark delta. Then draw the elastic curve and mark the FPMs at both ends. Remember, whatever support given, fixed only. Then, if the FPMs are clockwise, use plus sign. If FPMs are anti-clockwise, use minus sign. So, for this term, sign is, if the FPMs are clockwise, use plus sign, because our sign convention in the class is clockwise positive. So, to decide sign here, you check the sketch and decide whether FPM is clockwise or anti-clockwise. Fully clear? I already told last time, waste of time. Full clear? This is told last time, but I want to make independent question. Okay, start. Now, without wasting time. FPMs, first consider loading. See, AB member, point load. This you know how to calculate. BC member, whatever support given, both are fixed. UDL, find the FPMs. If this is not clear, you are wasting your time coming to my class. Okay, now, next step. Theta A is 0. Now, write a sketch showing support settlement. They told only support B sinks. So A will remain there only, C will remain there, B will sink by 120 by EI meter. Okay, now consider AB. Note, theta A is 0, theta B is there. And see, tell me, with respect to A, B. A is upper level, B is lower level. Elastic curve goes this way. This I thoroughly told. If the elastic curve goes this way, preventing moment, you require anti-clockwise moment at both ends. Therefore, see class, I am explaining now. Both FPMs are anti-clockwise. Therefore, for this term, use negative sign. Clear? For this term, when you substitute, use negative sign at both ends. Okay, clear? Start. Now, MAB equal to, what is the formula? M bar AB, not, see, I have written, MXY equal to M bar XY, or here. So, M bar AB is minus 216 plus or minus 6 into, be careful, member has got 3 EI, don't forget it, 6 into respective EI, 3 EI into delta is 120 by EI by 10 square plus, this is usual, 2 EI by L into 2 theta A plus theta B, theta A 0, you add these two, see here, your EI will get cancelled. So you get minus 237.6 plus 0.6 EI theta B. Same way MBA. Same way write MBA. Theta A is 0. FPM first one is 144. Add these two. EI cancels. You get plus 122.4 plus 1.2 EI theta B. Okay. Now consider BC. 1 minute now. I want some space here. So I will remove that one. See, I want MAB is over, MBA is over. This I will not remove. I will not remove this one. I will remove other things. Why? To save the space, to write the terms. Okay, no need. Other things I will remove. This I will not remove. Okay, now, see there. When you consider BC, B is lower level, C is higher level. So therefore, it is this way. Delta is once again, see this distance, 120 by EI meter. This time, because it is this way, FPMs are clockwise. So class, both FPM clockwise, use positive sign for this term. Therefore, if I write now, I write here now, MBC equal to M bar BC. Where is M bar BC? M bar BC is minus 30 plus 6 into respective EI. How much EI? 1.6 EI. I am not using red color. Into delta is 120 by EI divided by 6 square into 2 theta B plus theta C. Both are there. You calculate this one. Therefore, your MBC will become minus 30. EI cancels. These two together will give you plus 2. Check the answer. It gives you plus 2. Check the answer. Check the answer first. It gives plus 2. Correct answer. I want to check the answer. Because if it is wrong, problem then later. When you add those two, you get plus 2. Is it correct? Fast. Is plus 2 is correct. Don't waste time. Today I want to finish all the 3 methods. Is correct. Plus 2 plus, then numbers are not calculated. I will calculate 4 into 1.6. I will calculate out 4 into 1.6 divided by 6 plus 4 into 1.6 divided by 6. See, plus 0.8. Okay. Plus, it is coming 4 into 1.6 divided by 4 into 1.6. Oh, sorry. I forgot right here. Plus, see, plus 2E into I by L. Oh, I forgot. 1.6 I by 6 into 2 theta B plus theta C. Or it will become plus 2 plus 2 into 1.6 divided by 6 into 2. Fraction comes 1 point. I want accuracy, not 6, 6, 6, 7. I want for this question deliberately 4/5 decimal. That much times EI theta B plus 0.53333 EI theta C. I want for more accuracy. This is MBC. Same way, MCB equal to M bar CB. Where is M bar CB? Plus 30. Plus 30. Then FPM due to delta is here. Same term. Plus 6 into 1.6 EI into 120 by EI divided by 6 square plus 2E into 1.6 I by 6 into 2 theta C plus theta B. Both are there. If you calculate, your MBC will become, this number EI cancels. This number will become, I noted down there, it will become plus 62. Correct? Check the answer. It will become plus 62. Plus 62 plus 1.06667 EI theta C plus 0.53333 EI theta B. Is that term 62 correct? Fast. If correct means over. 62 correct? It's okay. Now done. That's all. Now nothing is there. I can remove the entire board now. Why? None of them required now. I can, where is that? See, here. Ayo. Completely dipped in water. Therefore problem. Okay. I will remove everything now. None of them required because I want fresh space. None of them required. This FPM once again you are doing for MD and Kani. No problem. Therefore, the next step, I will continue here now. Anyway, you can note down later. Once you copy is one, rubbing is not a problem. Now, last step. What? Unknowns. Unknowns. Unknowns are theta B and theta C. Therefore, now you should know it. Unknown at B. Equilibrium condition at B. Not this way. Write systematically. Equilibrium condition at B is what? MBA plus MBC equal to 0. MBA is here. MBC is here. See. So, MBA plus MBC is 0. If you add those two, you will get equation number 1. That is 1.2 plus 1.06667. 1.2 plus 1.06667. It will come 2.26667 EI theta B plus 0.53333 EI theta C equal to MBA is 122.4, MBC is plus 2 equal to minus 124.4. Equation number 1. Then next unknown is C. Equilibrium condition at C is only one member is there. MCB 0. So substitute that. Here you substitute that one. You will get MCB 0 means you will get LMCB. MCB, where is it? MCB. Oh, this is not MBC. This is MCB. Okay. MCB. You will get 0.53333 EI theta B plus 1.06667 EI theta C equal to MCB minus 62 is your equation number 2. Over. Solving 1 and 2, you get EI theta B and EI theta C. Tell the answer. You get EI theta B and EI theta C. Okay, now, once you get EI theta B and EI theta C, I will do one thing. I will write here, substituting MAB, MBA, MBC and MCB. Result by what? This is the result by slope deflection method. All moments are clockwise positive. From here, go to star. Tell the answer. EI theta B, fast. EI theta B. Correct answer. At least 5 decimals. EI theta B, fast. Mode alpha A. You are not giving answer. Simultaneous equation. Number of unknown is 2.66667. Then 0.53333 minus 124.4. Then 0.53333. 1.06667 minus 62 equal to minus 38.91664, and other one is plus 2.66. Oh yeah, no, something went wrong. Tell the answer. Something went wrong. No, something wrong. Once again, it's solve. It is 2.26667, then 0.53333. You are not giving answer. Minus 122.4. 120.4 is correct. MBS 122.4. MBA and MBC. MBA is 120. Correct. 4 equal to, next one is 0.53333. Next is 1.06667 and minus 62 equal to minus 45.69995, and other one is minus 35.27516. Correct answer. See, you are not cooperating. If you do not cooperate this much, what I can do? This solution also you are expecting me to do. This much time, you would have done the calculator 10 times. See, again, no usual thing. After all, 2 unknown, 2 equation, again you are not giving answer. I don't know correct or not. Then this question will go to next class. I do not want to go to next class. 46.7 45 or 0.6 45.7 I think. 34.34. How it is possible? 2.26667 0.53333 minus 124.4 0.53333 1.06667 and minus 62. 46. Oh, it is 46 actually. Okay. It is actually exactly 46.7 because 46.7 because 999 is there. Other one is 34.775. Correct? 77505. Correct answer now? Okay. Now, with this data, you substitute. I will do one thing now. Substitute. I will have the answer here. MAB. Leave it now. Mode 1. MAB equal to, MAB is here. Minus 237.6 plus 0.6 into minus 46.7 is minus 265.62. Minus, after substituting, it is minus 265.62. MBA if you substitute. MBA 122.4 plus 1.2 into minus 46.7 will give you plus 66.36. This will come minus 66.36. This will come 0. Correct answer? Actually correct because I noted down the answer there. I know. See, my answer is there. Minus 265.62 plus 66.36 minus 66.360. Okay, answer is there. I already solved because this question I can solve without writing anything. By only seeing the problem and using calculator, I can solve. I have done it in the offline class. I have done it in front of students. They start wondering, sir, how it is possible? You don't worry how it is possible. All I am imagining. Okay, now, SD method is over. Remember, this is the closing part of SD method. I am not removing because I want it there. Okay, start. Now go to MD and Kani. MD and Kani's method will finish simultaneously now. Lastly, see, today we can finish everything. Why? Even if I do little fast, actually, class will be over before 8:30. No. I will do systematically. By 8:30, you can finish the class. Because there is two span, no difficulty. I don't know where I kept it. See, once again, dipped in water. Okay, water. It is actually telling me, use water so that display is clear. Okay, now, see correctly other two methods. And remember, whatever I told last time class for MD and Kani, you should go through that once again. Not simply come today and tell something is not told. What something is not told? Everything is told. Of course, those who are outsiders, for them limited information. Because this is a class for the group. Only part of some of the classes I am going to what? I am going to YouTube live. Okay, start. Now, I will do one thing now. I will start simultaneously moment distribution method and also I will start Tani's method. Okay, start. Now, one important. Correctly observe what I tell. For both MDM and Kani's method, first you go for important concept. Start. Go back to question. This is absolutely fixed. This is intermediate support. Therefore, it is considered as fixed. This is absolutely fixed. Intermediate support considered as fixed. But C is simple support. This time remember, it is simple support without overhang. So your C is full round. Correct? Simple support. Full round. Yes or no? Clear? Full round. Our crude method. Clear or not? Full round. Okay. Now, for both the methods, remember, when you find distribution factor here, this stiffness is I by L. Why? Far and A is fixed. But this stiffness is what? Simple support 3/4 of I by L. This is also clear? Tell me fast. Left side is I by L. B to A is I by L. B to C is 3/4 I by L. Okay. Now, when I send you PDF of 9 questions, all 9 cases are there. First question, both are fixed. Both I by L. Second question, this question only. Third question, left side simple support. Then right side I by L, left 3/4. So now you can do all 9 questions. Tell me. After this, maybe next week I will send you. Now you can solve all 9 questions, 2 span. Yes, okay. Now, right, if it is MDM, this much you have to write. Then calculation of distribution factor D. If it is Kani's method, calculation of rotation factor R. But you should do separately. Start. For MDM, joint. Only one joint is there. Which one? B. That's all. Member. 2 members are there at B. Left side is BA, right side is BC. Right? Relative stiffness. K. Then you write sigma K. Then lastly, distribution factor equal to K by sigma K. This is for MD method. Start. BA formula is I by L. BC formula is 3/4 of I by L. Remember, 3/4. Okay. Substitute I by L. 3i by 10. 3 by 4 of 1.6 by 6. Tell me. Add these two and tell the answer. Add these two and tell the answer. Add these two and tell me the answer. First, 3 by 10 plus 3 by 4 of 1.6 by 6. Add those two, tell the answer. Fast. Actually, I know the answer. It is 3 by 5, 2 by 5. Because when I set the question so that round number will come. And I do not want that 0.333 all. During setting only, I adjusted EI. But you should not see all those things. I by 2. Okay, I by 2. Now, tell the answer. Answer. 3i by 10 divided by I by 2. Answer. How much? 3i by 10 divided by I by 2. Is it 3 by 5 and is it 2 by 5? Correct? 3 by 5, 2 by 5, correct? Fast. 3 by 5, 2 by 5, correct? Okay, over, done. Now, don't go to Kani now. This is for MD method. Now, next step is, see correctly now, next step is calculation of FPMs and then go to moment distribution table. Yes or no? Tell me. Next step is calculation of FPMs and go to moment distribution table, get the final moment and go to star. Correct. Okay. Now, clear? No, you are not telling. That is the old one. Clear? Next step is what? Calculation of FPMs, then go to moment distribution table and then what? Go to star. Okay. Now do one thing. We will come later. MDM. You wait for some time. After you, now do one thing. Don't go to Kani's now. You go to Kani's book. Kani's method, you write calculation of rotation factor R. Same table, only change is it is R. R equal to minus half extra. Therefore, this will come minus 3 by 10 minus 2 by 10. Clear? Once again you have to write for Kani's method. When you go to Kani's method, same thing you write. 1 minus half extra minus 3 by 10 minus 2 by 10. Clear? Clear or not? Okay. Now, then in Kani's method, calculate FPMs and go to not MDT, then go to calculation of rotation contribution and go to final moment. Over. Now I will come back once again to MD method. Why? So remember, after I finish MD method, when I start Kani's method, I will tell you what? Rotation factors are over, FPMs are over, directly contribution. Okay. Start. Now. See, now important calculation of, I am doing what? I am continuing which one? Moment distribution method I am continuing. Calculation of FPMs. One note you have to write. In a slope deflection method, when you find FPM, you consider only loading and delta term comes in the equation. But in moment distribution method and also in Kani's method, while finding FPMs, consider not only loads, not only given loading, but also given support settlement. Right. Then you do one thing. After all the story, start. First write one sketch here. Given support settlement. Given support settlement. A is there only. See, C is there only. Your B will sink by how much? 120 by EI meter. Okay. Now start. First, consider AB. When clockwise positive, remember, clockwise positive. And all FPMs are in kilonewton meter. When you consider AB, one diagram you write for loading. One diagram for loading. A is here, B is here. There's a point load of 150 kilonewton. This is 4 meter. This is 6 meter. And span is 10 meter. Now, anti-clockwise here, clockwise here, you know formula W AB square by L square, W BA square by L square. Okay, start. And below you draw one more thing. When you go to delta, that EI required, don't forget, it has got 3 EI, don't forget that one. Then draw two parallel lines. Two parallel lines. See now, A and B. A is upper side, B is lower side. And relatively, the displacement, the delta is what? Delta equal to 120 by EI meter. Elastic curve will come this way. This is A, this is B. Since the elastic curve comes this way, both FEMs are anti-clockwise. See, I told you. See, if it goes this way, reverse it. I told you example of what? Driving a car, anti-clockwise. Therefore, I will calculate M bar AB, considering both is anti-clockwise minus 150 into 4 into 6 square divided by 10 square, and also anti-clockwise minus how much? 6 into EI, 3 EI, very important, 3 EI into delta. Delta is 120 by EI meter divided by 10 square. Tell this answer. Then EI cancels. Not EI cancels. Then M bar BA is plus clockwise WBA square by L square. This is A, this is B. That is 150 into 6 into 4 square by 10 square. Then plus minus. This is minus. This is also a minus. Minus how much? Same. 6 into 3 EI into 120 by EI divided by 10 square. EI cancels. Tell this answer fast. Tell the answer. Is it minus 237.6 and this is plus 122.4? Correct answer? Tell me. Minus 237.6 plus 122.4. Correct? Okay, done. Okay, now leave it. This I will remove now. Remember, what I am doing is for both the methods. Then consider BC. Sorry. Consider BC. Over now. Consider BC. BC. Some student will tell, sir, C is not fixed. While finding FPM, everything is fixed only. Length is 6 meter. There is a UDL there of 10 kN per meter. Anti-clockwise here, clockwise here. Both are WL square by 12. Both are WL square by 12. Then, and also it has got 1.6 EI. Don't forget. Now, draw two parallel lines. Observe the sketch. B is below, C is above. Now see, reversed. When I do AB, see, here left side is above, right is below. Now B is below, C is above, and the delta equal to once again 120 by EI meter. Elastic curve will come this way. Therefore, I told you, if the elastic curve goes this way, FPM will be clockwise. Be very careful, clockwise. So use positive sign. Therefore, your M bar BC equal to minus W 10 into 6 square divided by 12, then plus, why plus? Clockwise, plus 6 into respective EI, 1.6 times EI, don't forget it, into 120 by EI delta by 6 square. It will come plus 2. Correct? Plus 2 is correct. It will come plus 2. Plus 2 is correct. If it is over, another 5-10 minutes question is over. Plus 2. Okay. Now, lastly, M bar CB. M bar CB is clockwise plus 10 into 6 square by 12. But this is also clockwise. Plus 6 into EI is there. 1.6, don't forget. EI into 120 by EI by 6 square. EI cancels. It will come plus 62. Therefore, make a note for moment distribution method. See, I'll make a note here. I'll write a note here now. Therefore, for moment distribution method, FPMs considering both loading and given support settlement are clockwise positive, M bar AB equal to minus 237.6, M bar BA is plus 122.4, then M bar BC is FPMs plus 2, M bar CB is plus 122.4. It is plus 62. These are all kilonewton meter FPMs for MD method. Fully clear? And write and note, same for which one? Same for which one? Tell me. Same for which method? Don't waste time. Same FPM for. You should Carney's method. Here we will save the time. Same for Carney's method also. Therefore, remember, make a note. When you go to Carney's method, at that time, I will tell once again. All this what I have done for MD method, you should write once again. Clear now? Once again you have to write that sketch showing delta, loading and delta show it, add the value. You should write once again there. Clear? Okay, start. Now, we are right now in the MD method. See how fast MD method is over now. Now go to moment distribution table. Moment distribution table. Okay. So fast means, see now, you will start wondering why it is coming so fast answer now. Because only 2 span. I will finish both the methods now. Okay, now see. Right. Now start. I am continuing moment distribution method. I am continuing MD method now. All red color. Ayo, why don't know why? All are coming red color only. When not required, red will come in random. Okay. I am continuing what? MD method. Okay. Start. Moment distribution table. A is fixed end. Go here. B is intermediate support. C is simple support. Remember, C is simple support. That you should remember. It is a very full round is there. It's a crude method. A, B, C. Enter distribution factor 3 by 5 and 2 by 5. Write members here. AB, BA, BC, CB. Enter the FPMs. FPMs are minus 237.6 plus 122.4 plus 2 plus 62. First step, simple support, release the moment at C. Now I will not explain. There is a limit for explaining. Full round is there. Fully release, minus 62. Half carry over to far end. You are right. Minus 31. Therefore, add the value once. These are called initial FPMs or modified FPM. It will come minus 237.6 plus 122.4 minus 29 and 0. And remember, now this is simple support, No more carryover here. Block. Now start. Now these all cancelled. Start here. Add the two values. 122.4 minus 29. 122.4 minus, you write there, balance and distribute at B. 122.4 minus 29 coming plus 93.4. Change the sign. Minus 93.4 into 3 by 5 here. Minus 56.04 here. And 2 by 5 here. Minus 37.36 here. Fully balanced. Half carry over this side. Minus 28.02 over. No carry over that side. That's all. Correct? If two spans are there, that's all. See, last time earlier, you had to do the same thing at C. Then from B, there is some carry over to C. From C, some carry over to B. That will spoil the balance. Now, that's all. Over. Add the values and get the final moment. Final moment, all clockwise positive. What you are getting is MAB, MBA, MBC and MCB. 0, you add these two. I am not adding. I got a confidence minus 265.62 plus 66.36 minus 66.36 and 0. Tell me, result perfectly tallying with your T method? Fast. Result perfectly tallying with your T method? Yes, over. Now, go to star. Go to star. Okay, over. Lastly, solve by Kani's method. Okay. This is also over in no time now. See, today, see, till 8:30, we are almost finishing the question. Something wonder. Why? Settlement part you are doing, and also what? 3 methods are getting over. Okay. Go to Kani's method. Kani's method. Those who want write. First, all this note you have to write. Then, calculation of rotation factor. I already explained. Next, calculation of FPMs considering loading and delta. That also over. Next step is calculation of rotation contribution, that is M dash. For that, A is absolutely fixed. This is B. Okay, right here. This is B. This is C. C is simple support. Simple support. This is simple support. We are going to replace it by what? Imaginary fixed support, and this is C. C, and with contribution M dash CB 0. M dash AB, it is a solid fixed support, real 0. Okay. Now, this is your M dash BA, this is M dash BC. Okay. Enter here. Here what you have to do? Write rotation factor for BA, rotation factor for BC, ABC. Now, BA is minus 3 by 10, minus 2 by 10. FPMs are minus 237.6 plus 122.4 plus 2 plus 62. Now, very important. First, what you have to do? Where simple support is there, you have to release the moment there. Plus 62. Make minus 62. Half carry over here. Minus 31. Add the values. You get 0 here. Here you get minus 29. These are the modified FPM. Now, once you do this one, all this value gets cancelled. Add the 2 FPM here. How much it is? Minus 122.4 minus 29. 29 equal to plus 93.4 over. Now, take your calculator. Calculate contribution. Sum of the FPM value 93.4. this side far end is 0, this side far end also 0, multiply by this number here, this number here. Multiply by either side numbers. That is 93.4 into 3 by 10 will come 28.02 minus, this all thoroughly explained for you earlier. This is minus 18.68. Remember, that's all. Why? If it is a 3-span problem, you have to go to next purport, do something there. When you do something there, that value will change, this will change. When you change here, that will change. See, to and fro motion. This time nothing. Fully clear? Fully clear? Over. Full clear. No going here and there. One cycle, over. But show the calculation. You show the calculation. That I explained to you long back in YouTube. Clear or not? First. If it is clear, I will go to next last part. You are not telling. If clear, I will go to last part. Calculation of final moment. You are not commenting. Only one cycle. Okay, now last step. Calculation of final moment. Right. mxy equal to m bar xy plus 2 times of m dash xy plus m dash yx. This is called FVM. This is called rotation contribution at a near end, rotation contribution at far end. Why not writing? I am telling 1,000 times earlier. You write it. Now, I told you this equation. Now, you calculate MAB, MBA, MBC and MCB. But before calculating, tell me this equation you should not use at which support? Fast. This equation you should not use at which support? I am shouting class after class. Simple support. That is where? C. So at C for MCB you should not use it. Whatever modified FPM is there, that itself is the answer. Over. Remaining value you calculate. Tell the answer. MAB you calculate. Minus 237.6 plus 2 times 0 plus minus, okay, I will write, actually should not write, minus 237.6 plus 2 times of 0 plus minus 28.02. Tell the answer. Let me see if any answer, different answer comes from SD method. Let it come if enough courage is there. Answer, I am telling. Let me see which beam has got courage to give different answer. Minus 265.62. Minus 265.62 kilonewton meter, all clockwise positive, go to star. MBA plus, see this moment, 122.4 plus 2 times of minus 28.02 plus far end is 0. Wait, leave it. I know the answer. Plus 66.36 kilonewton meter. MBC minus 29 plus 2 times of contribution there. Minus 18.68 plus far end is 0 will come minus 66.36. All the values perfectly tallying with the SD method and also perfectly tallying with the MD method, not decimal difference. Yes or no? Not even decimal difference. Okay, now see it's only 8:35. So I will do one thing now. I will complete the question by going to star. But before going to star, you should do something. Okay, start. Lastly, go to star. Go to star from SD method. Go to star from MD method. Go to star. Sometimes newcomer will ask star. I told star means SFDBMD. In the star, common calculation of vertical reactions. Consider AB span, AB span, this is VA, this is VB, point load, and MAB is anti-clockwise this moment, MBA is clockwise this moment. VA, VB1, get the two values. Then comes here BC span. BC span has got reaction VB2 and VC, and span you write, UDL is there. Left side anti-clockwise moment 66.36, right side 0. Find the reaction. Now you should type the answer for me. You should type correctly what is this reaction, what is this reaction, what is this reaction, what is this reaction. Agreed? In the same order you should type VA, VB1, VB2, VC. If you type that answer, I will go for SFD BMD. Agreed? I will give you 5 minutes time. Agreed? Moments are here. See, moments are here. If you are... Okay, start. I will give you 5 minutes time. In the 5 minutes time, you type the values. Actually, I know the answer. I noted down. No, I want it to come from you. I want it to come from you. See, here, anti-clockwise 265.62, clockwise 66.36. Next span, anti-clockwise 66.36, right side clockwise, right side 0. Type the value. I will come in 5 minutes and complete the question. Okay. Take 5 minutes time. Okay, someone gave the answer. I'll give small information. Okay, start now. Okay, anyway, your comment box I am not seeing. I will tell you what answer I got. You check the answer. I will do one thing. I will enter the answer. Then you check it. Okay, start. Your answer is there. Then I will enter my answer. Okay, this all I can remove. Nothing required now. This everything can be removed. We can go to final SFD BMD. Just a minute, it should get dry. It will take few seconds, maybe 30-40 seconds. Otherwise, the color will not be clear. Okay, now, what you do? First see, somewhere here, I will write the member. Little down, space problem. Okay, here, I will put the member. How much? 10 meter. Some scale required, 10 meter and then 6 meter. There is UDL here of 10 kN per meter. And there is a point load of 150 kilonewton here. This is 150 kilonewton here. This distance is 6 meter. 6 meter. This is A, this is B, this is C. This span is 10 meter, this is 6 meter. Okay. Now, this is a question given with so many. After MD, SD and Carney's method, you first got member end moments. Enter here. Member end moments. We got anti-clockwise of 265.62 kilonewton meter. You got clockwise moment here of 66.36, anti-clockwise of 66.36 kilonewton meter. Here 0. Then using that moment, you get this reaction. This is reaction VA. This is reaction VC. Here you will get VC1 and VC2. Then finally you can write the final VB. If you want, you can write I am not interested. Okay. Start. VA I got 109.926 kilonewton. 926 kilonewton. First VB I got 40.074. 40.074 kilonewton. Next member I got 41.06 kilonewton. 06 kilonewton. Next lastly VC I got 18.94 kilonewton. Is the answer correct? Is it same as what you got? Tell me. Is it same as what you got? 109.926, 40.074, then 41.06. Yes, correct. Okay. Now, draw SFD. Draw SFD here. Okay. This is not writing. Get a new pen. Red color is not required, but still I prefer red color for baseline. Baseline, I use red color. I am not writing. Usual problem. Okay. Why red color? Any color will do. Okay, baseline. This is the shearing post diagram. All values are kilonewton. Left up, right down, positive. Start. Go up by 109.926. No load up to here. Come down by 150. It will be only 40.074. Don't write minus here. Some people they write plus here, later minus, and again write minus. Little common sense required. Then, slightly out, is correct. Then here, go up by 40.074. SFD for AB is over. Then BC, go up by 41.06. 06, come down by 10 into 6. You will reach here 18.94. It will come this way. Go up. Now, this point I will call D, this point I will call E. D is known, E you have to locate. Locate from this side. Any side you can locate. If you locate that point will come, distance will come 18.94. There is a calculator. Oh, 10 na? 10 means I don't require calculator. 1.894 meter will come. 894 meter will come, calculate value. Okay, now go to bending moment diagram on tension side. BMD on tension side. That is what practically you require. No plus minus. So I will not explain too much. Bending moment here minus 265.62. Minus means hogging. So tension upper side. How much? 2. This all I explained for you in the group. I will tell you information afterwards. I will tell now only. See, this is the course for those who joined the group. Some of the classes I am making live in YouTube to benefit others. If I would have found good response, people come in good number and participated, then I would have done more classes on YouTube also. Even after today I am going to frames. When I go to frames, I will once again go to Zoom, only for the group. When sway comes, maybe one question on sway, SD, MD and Kani, I will do in a YouTube. But therefore, because people are not showing good response, lazy, not attending class, they are losing. If they thought that much, oh, this person is taking so much effort, let us encourage him by attending in good number and commenting. Then I would have taken more and more class in there. Not every class, at least more useful. You have to blame yourself only for that one. Okay. Here bending moment minus 265.62 minus 265.62 plus 109.926 into 4. It will come plus. Plus means sagging. So below 174.084. Not 84. Here bending moment. Here minus 66.36. 66 is up to here only. Okay, only this much. 66.36. Now joined by a straight line. Joined by a straight line. Two counterflexure point will come. Those who want can locate. No plus minus. Once you write BMD on tension side, sign is not to be used. Now here BM minus 66.36. Here BM 0. You also require BM here. I calculated that one. Plus 17.93618. Plus means sagging. Small value. 17.93618. You can look here. 18.94 into 1.894 positive minus 10 into 1.894 into 1.894 by 2 joined by a parabola. This is the little out of scale. Okay, actually this point is here. Okay. This is the bending moment diagram on tension side. And so many people, they want superimposing principle. Usually academic. For them, I will write once again here. Those academic point of view. Then you write BMD sagging positive. Okay, start. Hogging 265. Upper side you have to write 265.62. And here hogging 66.36. Here 0. Whatever load given, joined by straight line. Then superimpose bending moment diagram due to simply support beam. It is WAB by L. 150 into 4 into 6 divided by 10. 260 here. See, it is 260 here. How we got? WAB by L. Positive, light upper side. Then this is negative, this is positive, and this is negative. Here superimpose WL square by 8. 10 into 6 square divided by 8. 45, somewhere here. Center, 45. WL square by 8. Because benefiting for those who are okay. Minus and plus. This is the BMD by superimposing. Practical oriented, you never do this way. This will not give complete answer. It will give only shape of the BMD. Correct concept is what we are doing in the class. Clear? Yes. Now we are going to frames. Next week we are starting frames. Class will be again in the Zoom only. Till I reach sway case, one critical sway question I will do in YouTube. For SD method, for MD method and Kani's method, one sway question I will do, so that so many people got confusion in sway. But they will have difficulty because so many concepts are covered in the earlier classes here for frames. That all they are losing. But they would have got that also. Maybe some of the frames I would have explained in the YouTube only based on response. Now too late. Okay, thank you. See, till 8:53. Remember, we solved a question with support settlement by SD method, MD method, Kani's method, including SFDBMD. Class started at around 7:35, 7:40. So nearly 1 hour, 5 minutes rest are taken. In 1 hour time, we complete everything systematically. Now, practice the question. Coming week, I will start frames in the group only. Okay, thank you. Class